Hello and welcome back to the Core Learning channel. Today we're going to be looking at the quadratic formula. What is the quadratic formula? So, as we've discussed previously, we have a quadratic equation which has the standard format ax squared plus bx plus c equals 0. Now, you may have already come across the idea of factorizing quadratics, and this is where we put this type of quadratic equation into two brackets. Now, sometimes we can do this, but a lot of times we might have numbers that don't allow us to easily factorize. This is where the quadratic formula can come in really useful. So I will go through how we derive this, but for now, here is the quadratic formula. So our solutions for x for the quadratic equation is going to be equal to minus b plus or minus the square root of b squared minus 4 times a times c divided by 2a, where a, b, and c are the coefficients in the quadratic equation. So the quadratic formula can be used to determine the values of x that satisfy any quadratic equation. So you could use this formula even for the case that you have something that can be nicely factorized. If you use a quadratic formula, it will still give you the same answer as if you just factorized it. But as I say, in a lot of cases, you're not going to have a nicely factorizable equation, so it is quite useful to be able to use this. So let's have a look at an example quickly. So we've got 3x squared plus 7x plus 2 equals 0. So we want to know what our a, b, and c are, and then we're ready to use the equation. So in this case, our a is the term before x squared, which is 3. Our b is the term before the x, which is 7. And our c is the number term at the end, which is 2. So we're now ready to plug these values into the quadratic formula. When we do this, we're going to get that x is equal to minus 7 plus or minus the square root of 7 squared minus 4 times 3 times 2, all divided by 2 times 3. Simplified, this becomes minus 7 plus or minus the square root of 25 divided by 6, and this gives us our two values of minus a third and minus 2. And if we wanted to check, we could plug these values back in to the equation, so our 3x squared plus 7x plus 2. And when we do this, we should get 0 in both cases. So something that's quite useful to do and quite useful to know is something called the discriminant. So we've got our quadratic formula here. Now the discriminant is this part inside of the square root. So the b squared minus 4 times a times c. And this can actually tell us quite a lot about how many solutions there are going to be to the quadratic equation we have. So if we have that b squared minus 4 times a times c is equal to 0, then the square root of 0 is 0. And in this case, usually we'd have minus b plus or minus something, but in this case, minus b plus or minus 0 gives the same whether it's plus or minus. So when we do this, in the case where b squared minus 4ac is equal to 0, we're only going to have one solution. In the case that b squared minus 4ac is greater than 0, we will get two solutions. And in the case that b squared minus 4ac is less than 0, well, you can't take the square root of a negative number, so in this case there are no solutions. And this will come a little bit clearer when we go through some examples. So what I want to do now though, I want to run through the derivation for this. Now, you don't have to know the derivation at GCSE, but I think it's useful to know how we get these formulas. And if you do feel like you can keep up, then by all means, hang on for a few minutes and we'll go through how we actually get the quadratic formula. So we start off with a quadratic equation in standard format, which is ax squared plus bx plus c. And our first step is we want to divide through by a. So when we do this, well, the ax squared term, the a's get cancelled out, so we're left with x squared, and then we have a plus b over a times x term, and then we have a plus c over a term, and then we set that equal to 0. Our next step, we're going to rearrange the formula, so we're going to move that c over a to the right hand side. So it's currently a plus c over a, so we move it across to the right hand side as minus c over a. And this is the crucial step. We're now going to add b over 2a squared to each side. And the reason we do this is we want to get the left-hand side into a format that we can complete the square on. If you haven't already, I'd recommend looking at my completing the square video, as this might help clarify how we go about a few of these steps. So we've added plus b over 2a squared to each side. So we can now simplify. So x squared plus b over ax plus b over 2a squared, if you have looked at the completing the square video, we can actually simplify this left-hand side to x plus b over 2a all squared. And then we leave the right-hand side as it is for now. Now that we've done that, we're just going to look quickly at how we can simplify the right-hand side. So we've got this b over 2a squared term. Now what we're going to do is expand that out, and when we do that, we get b squared over 4 times a squared. And what we're going to do is we're going to substitute this value back into what was the right-hand side. So we've got minus c over a plus b over 2a squared. So this becomes b squared over 4a squared minus c over a. And what we want to do now, we'd like to be able to subtract the numerator here, so the b squared minus c, but to do that, we need to make the denominators equal. So the simplest way we can do this is we're going to multiply the c over a by 4a. So we're going to multiply c over a by 4a over 4a. So when we do this, we now have b squared over 4a squared minus 4 times a times c divided by 4a squared. And this can be simplified now. We have b squared minus 4 times a times c over 4a squared. So we're going to plug this back in from where we left off. So we had the x plus b over 2a squared, and that is equal to b squared minus 4ac over 4a squared. And now it's going to be a matter of isolating the x term by itself. So to start with, let's take the square root of both sides. So the square root of x plus b over 2a squared is just x plus b over 2a. And then we take the square root of the b squared minus 4ac over 4a squared. Our next step, if you remember how to divide surds, so if we have a big surd with a division in it, we can divide, we can put square roots for the numerator and the denominator here. So the root of b squared minus 4 times a times c over 4a squared can be rewritten as the square root of b squared minus 4 times a times c divided by the square root of 4a squared. So when we simplify this, we have the square root of b squared minus 4 times a times c, and then this square root of 4a squared is actually just 2a. And don't forget the plus or the minus sign, because obviously when we take the square root of something, it can be the plus or negative version of that number. And our last step, we now have our, we need to move the b over 2a term across. So we need to move it across as a negative. So we have x is equal to minus b over 2a plus or minus the square root of b squared minus 4 times a times c over 2a. We can see the denominator is the same in both cases, so we can just add the numerators. When we do this, we get minus b plus or minus the square root of b squared minus 4 times a times c divided by 2a, which is the quadratic formula. So let's go through a few examples to see how this actually works in practice. So our first example, we have x squared plus 5x minus 15 equals 0. And we want our answers to one decimal place. So the first thing we're going to do is we're going to work out what our values of a, b, and c are. So in this particular case, there is nothing before the x squared term, so we can just say that a is equal to 1. Our x term has a 5 in front of it, so b equals 5, and our c term on the end is minus 15. The next thing we're going to do is to check the discriminant. So our discriminant, if we remember, is b squared minus 4 times a times c. So in this case, we have 5 squared minus 4 times 1 times minus 15. When we simplify this, we get 25 minus 60. So watch out for that double negative. And when we simplify this is root 85. Now, because the discriminant is greater than 0, we know we're going to have two solutions. So in this case, we have x is equal to, and going back to the original quadratic formula, so it's minus b plus or minus the square root of b squared minus 4 times a times c over 2 times a. This becomes minus 5 plus or minus the square root of 85 over 2 times 1, which means our two solutions are minus 5 plus root 85 over 2 and minus 5 minus root 85 over 2. So just remember we've got this plus minus term, so we have to do an answer for plus and an answer when it's minus. So when we write this out in decimal form, our answers are going to be that x is equal to 2.1 and minus 7.1. Another thing we can do here that kind of helps visualize this is if we plot the graph of x squared plus 5x minus 15, then these values that we've worked out are going to be where we cross the x-axis. So we can see here we've got minus 7.1. Yep, it looks like it crosses at minus 7.1, and we've got, I've written minus 2.1, that is meant to be 2.1. So we can see that it crosses where it should cross. So move on to the next example. We have 2x squared minus 3x minus 11 equals 0. So again, we're going to write out our a, b, and c terms. So our a term is going to be 2, our b term is going to be minus 3, and our c term is going to be minus 11. We'll check the discriminant. So b squared minus 4ac, this is going to be minus 3 squared minus 4 times 2 times minus 11. When we simplify this, we get 9 minus 88, which is the square root of 97. Again, this is greater than 0, which means we're going to have two solutions. So our two solutions in this case are going to be x equal to 3 plus or minus the square root of 97 divided by 2 times 2. Now notice the reason that it's 3 and not minus 3 is that in the quadratic formula, the first term is minus b, i.e. minus 3. So the double negative combines to make it positive. So you just have to be careful with the signage here. So our two solutions in this case are going to be 3 plus root 97 over 4 and 3 minus root 97 over 4. In decimal form, this is 3.2 and minus 1.7. And again, I've plotted the graph here. So we've got the graph of 2x squared minus 3x minus 11. And we can see here that the points we've got are correct. So it crosses the x-axis at minus 1.7 and 3.2. So we'll now move on to the third example. So here we've got 3x squared plus 6x plus 3 equals 0. So again, we're going to write out our a, b, and c terms. So we have a equals 3, b equals 6, and c equals 3. We'll check the discriminant. In this case, we have 6 squared minus 4 times 3, which is the square root of 36 minus 36. So this is the square root of 0. Now, because the discriminant equals 0, in this case, we're going to have one solution. So x equals minus 6 plus or minus 0 divided by 2 times 3. So this just simplifies to minus 6 over 6, which is minus 1. And again, we'll have a look at the graph. So when we plot this, we can see it's going to be a quadratic, so obviously it's only going to have one minima, and we can see that it only touches the x-axis once, which is at the point minus 1. We'll do one more example, and then we'll have a go at some questions ourselves. The last one we're going to go through is 4x squared plus 7x plus 5 equals 0. So again, we have a equals 4, b equals 7, c equals 5. For our discriminant, we have 7 squared minus 4 times 5. This is equal to the square root of 49 minus 80, which is the square root of minus 31. Now, we can't have the square root of a negative number, so there are no real solutions to this problem. So this is the end of the question, which is that you'll state there are no solutions to this particular problem. And we can see this when we plot this. So you can see here that the bottom of the curve never touches the x-axis. So it's time to have a go at this yourself. So question 1, we have solve x squared minus 5x minus 13 equals 0. And I want the answer to one decimal place. When you're ready, pause the video and come back when you want me to run through the answer. So hopefully you found that okay. Let's run through how we're going to solve this. So hopefully your first step was to write out our a, b, and c values. So we have a equals 1, b equals minus 5, and c equals minus 13. We're going to check our discriminant. So b squared minus 4 times a times c. We'll just skip to that. So you should have root 77. This is obviously positive, which means that we're going to have two solutions. So our two solutions are going to be that x is equal to 5 plus or minus the square root of 77 divided by 2 times 1, which means our two solutions are 5 plus root 77 over 2 and 5 minus root 77 over 2. And in decimal form, to one decimal place, our answers are 6.9 and minus 1.9. So now for the next question, we have solve 7x squared plus 9x plus 3 equals 0. As always, pause the video and come back when you want me to go through the answer. So our first step is going to be our a, b, and c values. In this case, we have that a is equal to 7, b is equal to 9, and c is equal to 3. We're now going to check our discriminant on b squared minus 4 times a times c. So in this case, we have 9 squared minus 4 times 7 times 3. This is going to give us root 81 minus 84, which is the square root of minus 3. Now, as we've said, there is no solutions when we have negative square root. So there is nothing further to do on this question other than to state that there are no solutions to this particular problem. Moving on to question 3, we have 3x squared plus 14x plus 6 equals 0. And let's give our answers to two decimal places. So pause the video and unpause the video when you're ready. Cool, hopefully you found that okay. So our A term here is 3, our B term is 14, and our C term is 6. For the discriminant, we have 14 squared minus 4 times 3 times 6, which should give the square root of 124. This is obviously positive, so we're going to get two solutions here. So our x solutions are going to be minus 14 plus or minus the square root of 124 divided by 2 times 3, which is going to give us minus 14 plus root 124 divided by 6, and minus 14 minus root 124 divided by 6. And in decimal form, to two decimal places, our answers are going to be minus 0.48 and minus 4.19. So the last question we've got here is 2x squared plus 8x plus 8 equals 0. So pause the video and come back when you're ready to go through the answer. So in this case, our A term we have is 2, and we have B is equal to 8 and C is equal to 8 as well. So let's check that discriminant. So we have the square root of 8 squared minus 4 times 2 times 8, which is the square root of 64 minus 64, which is the square root of 0. So in this case, because our discriminant is equal to 0, we're only going to have one solution. In this case, our solution is that x is equal to minus 8 plus or minus root 0, which is just 0, divided by 2 times 2. So our solution is minus 8 over 4, which is minus 2. So as always, thanks for watching. Hopefully you enjoyed the video and learned something today. If anything is unclear or you have any questions, leave a comment and we'll get back to you as soon as possible. If you haven't already, please like and subscribe, and we'll see you at the next one.